guest today is Bill Steele. Bill, how are you?
I'm great, David. How are you?
I'm doing great. It's good to see you again. It's the first I've seen you since you started your next career.
Yeah.
It's a multiple careers.
Multiple careers.
You do a lot of stuff.
Yeah.
You
I like
teach,
to have fun.
and
I teach.
What else?
Well, I still fly.
You fly.
And I do a few things around that still, just playing around. And I also do 3D printers.
3D printers. And this is a 3D printer right here.
Yep, this is a MakerBot.
Okay, I know what a printer is.
Okay.
Yeah.
So you know how a printer.
And I know what 3D is.
A printer lays ink on a flat sheet of paper.
Okay.
Right. That's a 2D printer.
Yep. The sheet's flat.
Right. So what if we turn that up so that the ink, we printed one layer, put another piece of paper there, we printed another on it, put another piece of paper and printed on it. If we actually look at the ink, that's three-dimensional ink, right? But instead of using ink, instead of using paper, let's just use plastic.
Okay.
Like a hot glue gun, just melt plastic.
All right.
We draw it on one layer, then we move the extruder, hot glue gun,
Okay.
move it up a millimeter, draw the next layer, move it up, draw the next layer, and we keep drawing things until eventually you wind up with a full three-dimensional object, layers at a time.
So this is plastic melted with this hot glue gun and kind of fused together.
Yep.
Okay. All right. So, and I saw that you were moving your finger around here. That sort of implies that there's a mechanical device that is physically moving.
Yes.
As opposed to like a laser printer, for example, where you sort of magnetize it and stuff magically sticks to the right place.
Right. This printer takes this ABS plastic. It's just welding wire basically, and we force it down into, using this motor, down into this lower portion, the hot end. And the hot end actually has a chamber in it that melts the plastic, makes it molten, right? And then we force it down through the extruder tip down onto this build platform. And this build platform is hot. This is hot. And that plastic just sticks to that build platform. And as we move the build platform around under that extruder, it just lays out a pattern.
Oh, very cool.
And then we just raise the extruder up one layer, print the next layer, we raise it up another layer, and we keep doing it until the part's done.
So how long does that take to build something like this?
Oh, just a couple of minutes.
A couple of minutes?
Yeah.
Are there limits to what I can build? For example, does this turn at all?
No, that's actually one part.
That's one piece.
I just cut the plastic off in the middle and changed the color.
Okay.
I didn't stop
But could I build something mechanical itself that
You
has
could.
moving parts?
You could. So, for example, this was printed in one part. It's got some nice design features in it. You can see all the layering inside of it. This is Yoda I just printed out, and you can see it. It doesn't look very good right now, but in reality, this is kind of like one of the Michelangelo things. The art is inside the block, right? And you chip away. Well,
inside the block, the art is
right. Yoda. So if you look very carefully, you can actually see Yoda's ear sticking in here.
Okay.
And the reason all this gunk is around here is that we actually built a scaffold in the print. And it scaffolds that up because it knows that if I just print it out in the middle of the air, the plastic would just droop down and touch the bottom. So we build a little scaffolding up.
And then you trim that off.
And then we trim it off and we're done. In fact, this stuff is so easy, it literally will just snap off here. Okay, and you literally just twist, break it off.
Very cool.
And you keep doing that until you're clean, and then you just use a razor blade to trim off all the extra hairs and stuff that it connected. And you'll find that Yoda's nicely printed underneath of that.
All right. All right. So this is are you selling these devices or are you selling the product device?
MakerBot Industries actually designed this part. In fact, Bree Pettis and his crew actually invented this printer. They designed this printer originally. And I looked at that printer and I said, oh yeah, I really like the printer. It has a couple major faults. If you look at the picture on this one, you see they have all their belts and pulleys on the outside. They have all their electronics and all these wires and stuff hanging around. Well, you know me, I travel around.
Yep.
Well, I can't have a machine like that traveling around.
It'll fall out of the airplane.
Yeah. Well, not only that, but all these cables are going to get snagged on something. I'm going to tear it up.
Right.
So I redesigned his printer. I eliminated all the drive system. I eliminated all the electronics. And they're all buried down in the bottom here, nice and tucked away, so that the machine is nice and portable. Nothing sticks out. I'm not worried about breaking it. And that got me thinking about, well, what other things can I fix? And the other issue that these things have is that they have a very small build platform. It's a little 4-inch square, which means that the largest parts I could make were 4 inches by 4 inches and about 5 inches tall.
Okay.
And I thought, wow,
It's not big enough for you.
no, nothing is. So I wanted to make a bigger one, but I love the size of this machine. So I thought, well, what's the maximum size part I can make with the machine without increasing the size of the box? So I sat down and rethought this whole printer And I realized that what they're doing is they have a stationary extruder head and a mobile build platform. Well, the build platform is 4 times the size of the extruder head. So why not move the extruder head and leave the build platform alone?
Okay.
So that's what I did. I basically took all of their design and I inverted it.
Right.
So I moved the XY axis to the top with the extruder, and I moved the build platform onto the shelf, the Z axis, into the bottom. And that's what this acrylic machine is.
Okay, this is the one that you can buy from the inventor.
This is the one
your
that we
version
sell, yeah.
of it. Okay.
Yep. This machine is, you can see the extruder is up here at the top, and we have the build platform here. The build platform doesn't move side to side, it moves up and down,
I see.
which is backwards from what the original MakerBot did. Yep. So that's the machine that I've designed.
What's this here?
This is actually an interesting little device called the CNC. All of these devices are based off of the original RepRap project, and Adrian Boyer in England actually designed this RepRap. And the second generation machine was called Mendel, and that's the one pretty much everybody bases their machines off of. This is a derivative of the Mendel, so it is an open source design. The neat thing about this, guys, this is an incredibly low cost machine. It's about $350 to $500, depending how you configure it. But what's neat about it is the parts aren't printed like the RepRaps are. In this case, all the parts are injection molded. So the guys that designed this built it in such a way that they designed it to be as low cost as possible. And injection molding is really, really cost effective. So that's my CNC. Just as a, it's not quite finished yet, but it's a pretty nice little machine.
What are you selling your machine for?
This machine is about $1,000. It varies from, if we get it in a wood kit, it's about $700, all the way up to the acrylic fully built machine, it's $1,000.
Tell me the software over here that you're using.
The software is kind of cool. You can use any 3D design modeling tool that you want to. I personally use Google SketchUp. Google SketchUp is free from Google. In fact, it just sold. Trimble GPS bought it. And this is I noticed that you had this little Telleric bottle opener, and I figured I'd show you how to make a bottle opener.
Okay.
So this is a penny bottle opener. It's called a coin-operated bottle opener. And it's a 3D design that I have in here. And you can see that it's got a little slot here for the penny. And then what I do is I save this out and load it into this tool called Replicator G. Replicator G is actually a software that will take my three-dimensional model and it'll take it and it'll convert it into those slices. So it slices it up and calculates the tool path for each layer. And the tool path is the direction that we move the part underneath the print head. So it actually calculates that all out. And then once it's done, it generates what's called G-code. And G-code is a very machine-specific language. It's a standard in the CNC industry that allows us to...
So CNC is?
It's computer numerically controlled machines. It's all automated machines. So this is a standard that was developed a long, long time ago. And it's what our machines actually run off of.
Okay.
So then we take this G-code and we actually feed it to the MakerBot or the UltraBot. And it follows those instructions and prints out the parts.
Very cool. Can we see a demo?
Sure. I'll tell you what. I have this part actually ready to go. I can just say print, and we'll go down here. That was called a penny bottle opener. So we'll hit OK on that. OK on that. And now what it's going to do is it's going to move the extruder out of the way, and I'll pull off this garbage out of here. And after 10 or 15 seconds, what it's going to do is it's going to do a test extrusion. The test extrusion is used to clear out the chamber and make sure that it's up to temperature before we actually start printing the part. So it usually takes 10 to 15 seconds for this to happen. And what it does is it ensures that the temperatures of the extruder and the print head are both up to temperature, or the print bed are up to temperature. And it allows us to see that the extrusion actually works, so that it's fluid enough to come out. It'll take usually 15. Software hasn't reported the temperature yet.
Okay. I'm gonna do a little time lapse here.
A little time lapse, good. I keep my fingers on top here to feel it. I can feel when it starts tugging it, so I know when it's working. There it is. Now it's pulling it. and I snap it off right at the bottom there. And I'm going to adjust that ever so slightly up.
So while that's running, I see we're already on the second layer right now.
It's actually the first layer. It's actually just filling in the first layer.
Okay, all right. So let's just fill in. These are cool. These are almost like toys. Yoda, little blocks here. Tell me about some of the practical applications of this.
So practical applications are interesting. Anything that you can make in plastic, you can make with this.
Okay.
In fact, there's things that you can make in plastic with a MakerBot that you can't make any other way. For example, we see this part here, but what we can't see is that this part is hollow. Okay, and there's no way to make that. You know, it's one part, one piece that's completely solid from the outside wise. On the inside, here's another part that's solid. We can prototype parts. That's what I originally got into the MakerBot for. Prototyping parts three-dimensionally is very, very cost effective. It was cheaper for me to buy this machine than it was for me to send out to have my parts made. Okay? And the kicker is I can get it done in an hour.
Right.
But what's the best way to test a compiler?
F5.
No. What's F5 do? It runs the compiler, right? But what's the best way to test the compiler?
To write the compiler itself
To write
in
the
the
compiler in the language that the compiler is designed to compile, and write. The best way to test a 3D printer is to print out a 3D printer. Okay? This is a 3D printer.
No way.
Printed on a 3D printer.
No way.
As a matter of fact, this printer was actually printed on that printer.
Wow.
So it's completely made up ABS plastic.
Very nice.
So what can you make with a 3D printer?
A 3D printer.
Anything you want to.
Aren't you worried these things are going to become self-aware and then start self-replicating themselves?
Interesting. There's a funny thing that goes on in this. One of the concepts around the 3D printer was that nobody can make a business out of selling them. And the reason they couldn't do it is they would sell one printer,
Make more.
and it would print out a printer. They could get the print, and those two would print out, and nobody could sell printer because the first one was given away, and that's what Adrian's originally. But we found that one thing that the reason I went ahead and got into the business was that I found out that people like printers, but not everybody has the talent that they think they do or that they want to have to build one. Right? So we sell it as a complete machine as an option. It does, you can buy it as a kit if you want to, but you can also buy the whole thing from us completely built, assembled, and tested.
So this business is your web presence. People want to buy this.
Ultrabot.com. It's ultra-bot.com. And we're going to be setting up a Kickstarter actually next week. Kickstarter.com is a website where you can go put an idea and people can pre-purchase stuff from you and basically let you know if your model is viable or not. And then if it is, they basically pledge a certain amount, like they pledge to buy a machine. And if the funding is successful, if we reach our targets, then everybody gets charged and we get the money to sell the machines. So it lets us set up a company, or we have very, very little risk. But the nice thing is if we see that we're not making the target, maybe there's something that we need to rethink in our business model. We can reiterate it, resend it.
Sounds agile.
Yep, exactly.
Anything else? Is this part of it? What is this?
Oh, this is actually an RC car. This is a remote control car. This is actually a design out on Thingiverse. Thingiverse is a website of things. We call it a universe of things. Anything you can think of, like this rep part. This is actually, the design is actually published out on Thingiverse.
So this was made like this?
Yep. And this car is a design that was out there, and a lot of guys were building it. And I decided to build one. This was printed on a little bit larger machine. It's that design over there, but this printed out. The whole shell is
one piece.
One piece.
Wow.
The spikes were printed on one plate, so there was 12 spikes printed at once. The shell was printed one piece, and the chassis was printed one piece. This took about 3 days total for this to print. I just started the printer and let it run continuously until it was done.
That's very cool. Anything else?
And it's printing out you can see our...
let's look at this thing here.
Here's actually completed ones right here.
Oh, okay.
This is fresh off the printer, uncleaned up. So what we'll do is we'll just take a razor knife and just clean up these little strays. And then this is one that I printed earlier today with a penny inserted. That's why it's a coin operated bottle opener. So same concept that you have at Teller.
Good commercial.
So you gave me a bottle opener, you can have my bottle
For
opener.
me, this is turning out to be a really, really good day. Bill, thank you so much.
Thanks, David. Well, what I like to do is give this kind of technology to all my friends.